Hello, my dear friends. Today we are going to see this topic. It's the last topic of this chapter of Class 12 Chemistry, Chapter 5, Importance and Applications of Coordination Compounds. There are a lot of applications for coordination chemistry that ranges from chemistry, analytical chemistry, industry, medicines, and biological systems. And all these applications are compiled below as points. First is application of these compounds in qualitative as well as quantitative chemical analysis. What is chemical analysis? Chemical analysis is a analysis or testing of presence or amount of compounds, chemical compounds that is present in a sample. Qualitative means finding out which compound is present in the mixture, and quantitative analysis means how much of a particular compound is present in a sample. And this is useful for this use of chemical coordination compounds is useful in chemical analysis. One of the main reaction is that color reaction, because we know metal coordination complexes are colored ones, are highly colored. So when using ligands, especially chelating ligands, chelating means those ligands which will form a ring kind of bond with metal. So because of this chelation, this use of coordination compounds is useful in estimation of uh, classical as well as instrumental methods of analysis. Examples of such ligands are this: EDTA, DMG, dimethyl trioxime. EDTA is ethylene diamine tetraacetate, and alpha nitroso beta naphtha. All these are chelating ligands which, when interacts with the metal, particular metal, will give a characteristic color to the mixture. So we can know whether this metal is present in this mixture or not. So that is first useful in the chemical analysis. Keep in mind chelating ligands and examples: EDTA, DMG, cupron, alpha nitroso-beta-naphthol, etc. And second is for analyzing hardness of water. This hardness of water is estimated by titration with sodium salt of EDTA. What happens is that the permanent hardness of water is given by calcium and magnesium ions in the water, and when these are treated with sodium sort of an EDTA, this calcium and magnesium ions will form more stable compounds with the EDTA, so that what is left behind is analyzed to get how much of hardness is there for the water. And the selective estimation is done using measuring the stability constants of calcium and magnesium complexes, that is obtained directly from the titration values. And the next important application is in the extraction of metals. For example, silver and gold extraction use the complex forming reactions. For example, gold combines with cyanide in presence of oxygen and water to form a coordination entity in aqueous solution. So what happens is that gold is present in gold AU is present in an ore as a mixture, and it combines with cyanide in presence of oxygen. So gold extraction is using cyanide, you know it. So they form a coordination entity like AuCN 2 times in aqueous solution or minus charge. This is separated as metallic gold if we add zinc. So this is the extraction of gold that is happening. Sorry, not AG, AU. AU is gold. So this is what happens for the extraction of gold. Now coming to the next application, that is purification of metals. So this is also done with the help of complex forming reactions. So certain metals form stable complexes with certain ligands, and we will get stable complexes for this metals if present in a mixture. For example, nickel is converted to nickel carbonyl. So nickel Ni is, when treated with the carbonyls, is converted to nickel carbonyl, which is pretty stable and it is separated easily. And also coming to the biological systems, the application of coordination compounds in biological systems. We all know the pigment responsible for photosynthesis. What is it? It's chlorophyll molecule. Chlorophyll is a coordination compound of magnesium. Magnesium is the central metal atom for chlorophyll molecule, and it is this light absorption and all is happening because of this complex is there. Certain complex is there. That's why photosynthesis in plants is happening. Then coming to hemoglobin, which is the red pigment in blood. That is a complex of iron. We know iron is the central metal atom. So if we have deficiency in iron, what happens? Hemoglobin will not be formed. So the oxygen carrying capacity of blood is not there. So the oxygen will not be carried to all the tissues and muscles and cells. So what happens? If we generally fatigue and anemia, because we need oxygen for functioning. So hemoglobin is the red pigment of blood, which is acting as an oxygen carrier. It's a coordination compound of iron. So chlorophyll is there. It's a coordination compound of magnesium. Don't forget. And hemoglobin is there. It's a coordination complex of iron. And then there is vitamin B12, cyanocobalamin. It is an antipernicious anemia factor. So it prevents the antipernicious anemia, and it is a coordination compound of cobalt. So vitamin B12, it's a coordination compound of cobalt. So remember these biological systems where the coordination compounds is as given here. Chlorophyll is a magnesium coordination complex, and hemoglobin is an iron coordination compound, and vitamin B12 is a cobalt coordination complex. And most of the enzymes like carboxypeptidase, carbonic anhydrase, these all are coordinated to the metal ions, and they are helping in the activation of these enzymes. And coming to the industry, what is the application of industry? In industry, most of the catalysts are coordination complexes. For example, rhodium complex. This rhodium complex is known as Wilkinson catalyst. It's used for hydrogenation of alkenes. It's highly useful in many industrial processes. So Wilkinson catalyst is a coordination complex. What is this? Rhodium complex. Rhodium complex with chloride and triphenyl phosphate. Wilkinson catalyst structure is like this. Rhodium is there. Chlorine is one ligand, and other than that, pH3. pH is phenyl group and P is phosphorus. Triphenyl phosphate. So this is known as Wilkinson catalyst. This is used for the hydrogenation of alkene. So what is the catalyst used for hydrogenation of alkenes? It is Wilkinson's catalyst. It's an example for a coordination compound. And now coming to the other applications, electroplating of articles with silver and gold happens easily and smoothly if you use solutions of these complexes than solutions of simple metal ions. So in electroplating, plating industry also, coordination compounds are highly useful. So if we use gold solution, these smooth plating or smooth covering of the area is not happening. And if we are at the same time, if you are using complexes of cyanide with silver and gold, a smooth and even coating of this metals like gold and silver is possible. And then there is in photography, that's in black and white photography. In earlier times, you used to have still photography, black and white photography. The development of film is done. It is fixed with washing with a hypo solution. Dissolves the undercomposed silver bromide. So what happens is that there is in that photography, still photography, this film is coated with silver bromide. And when light comes into this film, wherever there is less light, the silver bromide will be deposited more. Or in other words, wherever there is light or there is a high concentration of light, the silver bromide will react and the concentration of it will be less. And when it is treated with a hypo solution, what happens? The unreacted silver bromide is removed as a complex of silver and hypos ligand. So this is happening in the developing of films in the case of black and white photography. And now coming to the application of it in medicine. So there is nowadays chelate therapy is useful in medicinal chemistry. An example is if toxic metals are present in plant or animal system, we use chelating agents to remove this toxic metals. For example, excess of copper and iron, if present, is removed by chelating ligands D-penicillinane and desferrioxam B. So they are forming coordination compounds and they are taking away these metals from the biological system. Also, EDTA is used for treatment of lead poisoning. And some coordination compounds of platinum is effectively useful for the removal of tumors, inhibiting of growth of the tumors. Example is cisplatin and their related compounds. Cisplatin is a platinum containing coordination complex. So in medicine, which all are the examples that is given here? Platinum tumor inhibitor. Then there is, if copper and iron is present, they are removed by chelating ligands and their toxicity is reduced. And this example of the chelating ligands are this, D-penicillamine and desferrioxam B. And EDTA, the ligand, ethylene diamine tetraacetate, is used for removing lead, thereby treating lead poisoning. And there is other examples also. So these all are the applications of coordination compounds. So broadly, it can be classified as chemical analysis, then biological systems, and industrial applications, then coming to last medicine. So these all are the things that you have to keep in mind. You study well. If you have any doubt, don't hesitate to ask in the comment section. Thank you for watching.